Now we're going to talk about solving parallel circuits with the matrix method. Alright, here is a parallel circuit. I've got a 90 volt battery connected to two resistors, a 10 ohm resistor and a 20 ohm resistor, and they're hooked up in parallel. Alright, I've pre-written this matrix here. We've got four columns. We've got the voltage, the current, the resistance, and the power. Then going horizontally, we've got the spaces for each individual resistor and for the circuit as a whole. I've pre-populated this with the individual resistances, the 10 ohms and the 20 ohms, and then the voltage of the battery. Alright, in a matrix problem like this, we can go horizontally, we can connect the data points horizontally using the formulas over here on the side. We've got the V equals IR formula and then the various power formulas. When we want to connect things going vertically, we use, in this case, the parallel circuit rules, which are down here along the bottom. Alright, these are different from the series circuit rules because we are here talking about a parallel circuit instead of a series circuit. We've got that the total voltage, the voltage of the battery, is equal to the voltage drop across each individual resistor. We've got that the total current coming out of the battery is equal to the sum of the currents going through each of the individual resistors or each of the individual loops. Then we have this equivalent resistance formula, which is 1 over the equivalent resistance is equal to the sum of 1 over the individual resistances. Alright, when we try to solve this problem, we look at it and we say, okay, the place I could start would be with the voltage rule here. We've got that the voltage of the battery is equal to the voltage drop across each individual resistor. Then I can use Ohm's law of equals IR to solve for the currents in each of the individual resistors. I've got a 90 volt battery or a 90 volt potential difference and a 10 ohm resistor, so I've got 9 amps going through resistor 1, and I've got a 20 ohm resistor for resistor 2, so I've got 4.5 amps going through resistor 2. I can continue by filling out things horizontally by saying, okay, the power in resistor 1 is 90 volts times 9 amps is 810 watts, and the power in resistor 2 would be 90 times 4.5, which is 405 watts. Alright, now I can try to solve for things for the total circuit, and I can see that the total current is going to be 9 amps plus 4.5 amps is 13.5 amps. Then I can solve for the total power. I can add up the powers in the individual resistors and get a total of 1215 watts, or I can multiply the total voltage by the total current and I get the same answer. Alright, now when we want to solve for the equivalent resistance of the circuit, there are two ways that we can do this. We can use the V equals IR formula or the equivalent resistance formula. Here we're going to try to check that they give us the same answer. Alright, so if I want to solve for R here, then I do V over I. And the voltage was 90 volts, and the current in the circuit as a whole was 13.5 amps. We divide those by each other, and I'm going to divide them, I'm going to make this a fraction first. So I get 180 divided by 27, which works out to 6.67 ohms is the equivalent resistance. Alright, now I can do this over on the other side. I can use the equivalent resistance formula. I get 1 over 10 plus 1 over 20 is 2 over 20 plus 1 over 20 is 3 over 20. That's 1 over the equivalent resistance. I'm going to do REQ then is equal to 20 over 3, which is 6.67 ohms. We get the same answer in both methods. All right, let's do a second one. We have a resistance, or we have a battery here, which is connected to three resistors, a 10 ohm, a 40 ohm, and a 70 ohm resistor. And what we know is that the 70 ohm resistor has 2 amps flowing through it. So again, I've set up this particular problem in a matrix. We've got the 4 columns, and we've got the 3 resistors, the 10 ohm, the 40 ohm, and the 70 ohm resistor, and we've got the 2 amps flowing through the third resistor. All right, so where can we start here? Well, we can go horizontally and use the V equals IR formula to figure out that we must have 140 volts of potential difference across the third resistor. Then we can use the voltage rule for parallel circuits to see that we have 140 volts across each individual resistor as well as across the entire battery. All right. Then we can use the V equals IR formula to solve for the currents in each individual resistor. We can see that we've got 14 amps going across resistor 1, and we've got, let's see, 140 divided by 40 is 3.5 amps going across resistor 2. We can add those individual currents up to get the total current in the system. We got 14 plus 3.5 plus 2 is 19.5 amps. And for good measure, we can calculate the various powers. 140 times 14 is 1960 watts in the first resistor. We've got 140 times 3.5 is 490 watts. And then 140 times 2 is 280 watts. And here, to figure out the total power, we can either add these together or multiply these, and we should get the same answer. We get 2730 watts in both cases. All right, now let's look at the equivalent resistance. We've got V equals IR. We can do R equals V over I. That's 140 volts over 19.5 amps, and that works out to be 280 over 39, which is equal to 7.18 ohms. All right, and on the other side, we can use the equivalent resistance formula. We get 1 over 10 plus 1 over 40 plus 1 over 70. So we're going to have 28 over 280 plus 7 over 280 plus 4 over 280 gives us 39 over 280 is 1 over REQ. Now you'll notice that this number here, 39 over 280, is 1 over this number here, which is what we expect because REQ should be 280 over 39 or 7.18 ohms.